the longitudinal section of these beams, and these are cross sections of these beams. Plan of this beam is over here for the grade beam, and you can check all of this as well over here. We have GB1 over here, we have GB2 over here, you can see we have GB3 over here, sorry 3 is over here. So likewise, if you can find out the one like GB1, the process will be same for GB2, GB3, GB4, GB5. So all we need to do is we need to go here and understand the drawing. Now for beam reinforcement, it is very important to have the longitudinal section and the cross section as well. Here we have GB1. You can see this is the longitudinal section, and it is clearly mentioned over here. We have how many supports? 1, 2, 3, 4 and 5 supports are over here for this beam. This is GB1. Let's go into the plan and check whether we have 5 or what. So here we have a GB1. This is GB1. Sorry, not GB1. GB1, 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 GB1 and GB1 up to this position. So how many supports we have? In the column C1, 1, 2, 3, 4 and 5. We have total of 5 supports. So it is okay. Now next to it, we need to verify this one. The first two supports, this one and this one, in between the distance is 20-25 mm. Let's check this one. Let's verify this one. It is important to verify this one. GB1, right from this position up till here, it is 20-25. DEL, it is 20-25. Next one over here is basically, sorry, it is total of 38-25. Let's check the next one over here. Yes, it is 38-25. So likewise, the first is 20-25, 38-25, 46-50 and last is 48-75. You can verify it in the plan as well. So this is the first check. You need to check center to center distance between two supports. Now next to it, this is basically outward dimension, means center to center distance between two out supports. This one and this one, it is 15.375 millimeter. Next to it, we have reinforcement details over here to understand. And for reinforcement, at the top we are using two main bars and 12 mm is the dia. This is main bar, and this we have only two bars, 12 mm is the dia. And next to it is mentioned over here as well. Next to it we have one extra bar as well. This is basically the extra bar, and one bars we have 12 mm is the dia. And we can find out the cut length right from this position. I'll let you know about how we can find out. And at this end as well, we have one extra bar, 12 mm is the dia. So this is basically the detail of the main bars and the extra bars at the top. Now let's move toward the bottom. At bottom we are using again the two main bars, 16 mm is the dia. So at bottom it is 16 mm, at top it is 12 mm. Next to it, at bottom we have one extra bar as well, this one on the mid support, and it is total of 1 bar, 12 mm is the dia. Now here in this we have two of the sections, section at 101 and we have section at 102. So from this we can get more detail. Like at section 101, what we will have, at the top we will have two main bars only, because we do not have any kind of extra bar over here. So at 101, at the bottom we will have three bars, two main bars and one extra bars according to the detail. So 2 at the top, 3 at the bottom. Let's go here in 101. 2 at the top, 3 at the bottom. Mean two main bars at the top, two main bars at the bottom, and third one here at the bottom is an extra bar. You can see the detail over here. Here as well. Now next to it, let's go into section 102. Now in 102, at the top we will have the 3 bars, mean 2 main bars and 1 extra bar, and at bottom we will have the 2 main bars. So 3 bars, 2 main bars, 1 extra bar is over here, and 2 main bars at the bottom. So it is mentioned over here, 2 main bars and 1 extra bars and 2 main bars. So this is basically section 101 and section 102. We can get the more detail like this from these sections. So next to it we have find out what the longitudinal bar, the extra bars. Now next and the most important is to find out the stirrups and spacing. Now we have different spans over here, span from first sport to another sport. We are using 6 mm bars, 200 cm for the stirrup. Again for the next sport as well, 6 mm 200 cm, 6 mm 200 cm, and 6 mm 200 cm to center. So in all of this beam we are using here what? 6 mm bar and 200 cm as a spacing. So this is basically the detail regarding the reinforcement in the beam. Now hope you understand this one. Now next to it, the important thing to understand over here is the total length of this beam. Now total length of this beam is 15375 millimeter into in, right from this position up till here. Now in order to find out out dimension right from this position up till here, we need to add the half thickness of this port at this end and half thickness of this port at this end. Now these are, remember, the column C1 225 mm, and this is also 225, so half will be what, 112.5 at this end and 112.5 at this end, mean total of 225. So from total this length, in order to find out the total external length, 15375 plus 225, 15600 is out to out dimension. Now 15600 mean the out to out dimension is basically 15 meter. Now remember one thing, if you have attended the BBS basics, you know the standard length of one bar is 12 mm in MK system. Standard length of one bar is 12 mm. Remember this. And what is the length of this beam? 15.6 meter. It's mean that our design length is greater than the standard length. Our design length here is greater than the standard length. So what we will do? We will provide here the overlap as well. So in the main bar, it is very important to add the overlap as well. This is what I want to deliver over here. So 15600 is out to out dimension, and the breadth and the height is 225 by 225. Let's go here in the Excel, start BBS over here, and serial number as 1, and then next to it, what I'll do, I'll write here GB1. Next to it, what is the length? 15600. We have find out it over here, 225 by 225. Next, particular placing of bars, so main bars, or you can say right here top main bars. Now next, spacing, there is no need to add the spacing over here for the main bars. Let's create the shape for the main bar. Click on this drop down, drop order option, and create a shape over here. We have two bends over here and the straight shape. Next to it, we need to do the bend directions over here. So we have two 90-degree bends over here. So equal to 2 into 2 into dia bar. It is where it is over here. Now next to it, we will go here in the bend at the development length. And bend in the development length, we have mentioned over here, we are taking here 12 into dia bar. This bend we are taking here 12 into d. So it is equal to 12 into dia bar. And what is the dia we are using over here? Yes, before that it is very important to add here the overlap area as well, because our design length is greater than the standard length. 12 meter is the standard length, design length is somewhere around 15 meter. So we need to add the overlap value as well in order to do the overlap. So overlapping is mentioned here in the journal notes. Go here. If it is, we have the dia bars and their overlap value, 6 mm, 225, 8 mm, 225, 10 mm, 250, 12 mm, 300, 16 mm, 325 and 20 mm, 375. So here at the top we have 12 mm bar we are using, 300 is the overlap value. So let's add it over here, 300. 300 is the overlap value. What about the dia bar? Dia bar we are using here 12 mm. Remember, and based on this you can see the bend directions over here as well. Concrete cover here in the beam. What will be the concrete cover? We have already took in the columns 25 mm, and columns and the beams the same concrete cover we will use over here, 25 mm. Next to it, a number of bars. We have 2 bars, the main bars multiplied by number of members. How many grade beams we have? The GB1. This is basically the longitudinal section. We can find out it from the plan. So GB1 at this end we have 1, and GB1 at this end. So we have 2 of GB1 over here. So in number of members we will put here 2, and then total numbers will be equal to number of bars multiplied by number of members. So at top we have 4, total of in 2 beams. And now it is time to find out the total length. In order to find out total length, it is equal to total external length, that is 15600, minus we need to deduct the concrete cover first of all. This is the horizontal length, and in this we need to add this overlap length as well to find out the final length. Important, this one. Now what about this hook length? It is equal to, hook length is over here, and this is also, it is equal to over here. So we have find out main bars at the top. Now in order to find out the total length, it will be equal to what? This one plus this one plus this one, and then we need to add the overlap value as well. It is very important. and then minus we need to deduct the bend directions, 90 degree bend. Now it is time to multiply it with total numbers, divide it on 1000 in order to convert it into meter. Hit enter. So we have total length over here, remember. Now next we will find out the main bars at the bottom as well, and we will do part 2 for this beam as well, in which we will find out the extra bars at the top and the bottom and the stirrups as well. Number 2 we have over here, number 2 and GB1, and it is same. So simply copy this one, paste it over here, and bottom main bars. Next to it there is no need to add the spacing over here definitely, but we need to create a shape for this, for the bottom main bars. So shape will be like this. Remember we have two bends over here and the straight shape. Next to it we need to go for the bend direction. Bend direction is same, 2 into 2D, because we have two 90 degree bends. We will put the dia over here in order to find out the values over here. What about the bend and development length? It will also be same, 14 into D. So paste it over here. You can see the value over here, 12 into D. Next to it we have to find out the overlap value as well. And what about the overlap? Yes, it is equal to, at the bottom remember one thing, we are using 16 mm steel. You can see in the drawing as well. Let me simply go here. At the bottom we are using 16 mm, 216 mm steel. So in order to find out the overlap value, we need to go here in the channel loads, and if it is 16 mm, then we will take the length as 325 for the overlap length, 325. So put it as 325. Next 16 mm is the dia. Based on this you can see the values over here. Concrete cover is 25 mm, number of bars we have 2, and number of members we have grade beams as what, 2, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. Now it is time to find out this horizontal length. It is equal to total out to out minus concrete cover from both ends. Hit enter. Let me drag it over here and move it toward this direction, and this is equal to, we have find out the bend and development length. It is okay, and we have find out it over here as well, and I'll simply move it toward this direction. No, it is in center. Next to it what we need to do is we need to find out the total length, and in order to find out total length, what I'll do, I'll simply go here. It is equal to this one plus we have this one plus this one, and then we will add the overlap value as well. This is over here, minus we need to do the bend directions over here. So this is the bend direction, multiply it with total numbers, and then divide it on 1000 in order to convert it into meter. Hit enter. So this is basically 64.7, the total length over here.